class, let's look at another example of trying to find f prime of x using the limit definition of the derivative. So let's say I have something that isn't a polynomial this time. We've done a couple of those. Let's say f of x is actually 1 over 1 minus x. Okay. And I want to find f prime of x using the limit definition. Right, the limit is h goes to 0 of f of x plus h minus f of x all over h. Right, so we start by plugging stuff in. 1 over x plus h, that will be 1 over 1 minus x plus h minus 1 over 1 minus x all over h. Okay. So the first thing we'll want to do here is let's simplify this out a bit. First, let's rewrite this so we don't have to write that parentheses every time we do this. So this will be 1 over 1 minus x minus h minus 1 over 1 minus x all over h. Okay? Alright, so first of all I should mention that if we just try and plug in 0, we're going to get 1 over 1 minus x minus 1 over 1 minus x, which is 0 over 0. So that's why we can't just plug and chug yet. And we have to, the motivation is to get h out of the denominator. So to do that, well, there are a couple ways to do it. You can just do brute force fraction arithmetic here. Another way to do this is if you have some fractions that you don't like, what you can do is multiply by the denominators on the top and the bottom. So if I multiply by 1 minus x times 1 minus x minus h on the top and on the bottom, well, this is going to actually cancel some values when I multiply it through. Okay, let me show you. I'm going to write it out completely. All right, it's going to be crazy, but you're going to have 1 over 1 minus x minus h times 1 minus x times 1 minus x minus h, and those cancel. This is going to be minus 1 over 1 minus x times 1 minus x times 1 minus x minus h, and these are going to cancel. And the whole thing, this is an easy part to forget, make sure you don't, it's going to be over h times 1 minus x times 1 minus x minus h. Now, often people don't actually write this step, but it is what is going on. We've canceled out those fractions, see, because now we have, okay, the limit as h goes to 0 of, we just left with 1 minus x here, so it's going to be 1 minus x minus, I'm going to leave it in parentheses for now, what we have here is 1 minus x minus h. Right, and the denominator doesn't change. And so I'm going to distribute this negative sign across, and we will get, actually, let me not do it here. Let me do the line. Sorry about that. Right, so let's say this is the limit as h goes to 0. This will be 1 minus x minus 1 plus x plus h all over h. It's 1 minus x times 1 minus x minus h. So we have the x's cancel, The 1's cancel, and we're left with just an h on the top. Okay, so this is going to be the limit as h goes to 0 of h over h times 1 minus x times 1 minus x minus h. And the h's cancel. Now, a common mistake I'm seeing is you're canceling out the entire fraction. Remember, there's a times 1 sitting here. That stays. Okay? So, let me leave some of this. So what we end up with is that this is equal to the limit as h goes to 0 of 1 over 1 minus x times 1 minus x minus h. Now I can actually plug in 0. Because if I plug in 0, what I get is simply 1 over 1 minus x times 1 minus x minus 0, which comes out to be 1 over 1 minus x times 1 minus x, which is perfectly fine. Okay? So what we basically found here is that if f of x is 1 over 1 minus x, and f prime of x is 1 over 1 minus x squared. Okay? You're going to have to use what you know about limits, use what you know about algebra and all that to actually get values out. Okay? So just take it a step at a time, and you'll be fine. Okay, let's try another one. Let's say we have the limit, or excuse me, let's say we have f of x is equal to the square root of x plus 1. Okay. And we want to find f prime of x. So f prime of x is going to be, and let me tell you, if you just write this definition every single time you have to use it, you'll have it memorized in no time. That's how I memorized things when I was in calculus. Okay. So, right, so we have the limit as h goes to 0 of f of x plus h. So that will be the limit. H goes to 0. F of x plus h, so that will be the square root of x plus h plus 1 minus the square root of x plus 1, right, minus f of x. So that one's not too bad. All over h. Now, what do you do when you have square roots? What do you do? Well, remember, you use the conjugating factor. So the conjugating factor, I have these two terms, my a, my b, and I just change the sign in between them. So I'm going to multiply the top and the bottom by the square root of x plus h plus 1 plus the square root of x plus 1. All over the square root of x plus h plus 1 plus the square root of x plus 1. Okay. All right, now we multiply this through, and I'm going to go ahead and put in my parentheses. A lot of you are forgetting to do this. That's bad, bad, bad. Make sure you put parentheses, you know, on whatever you're multiplying by, or put them around it. Okay. And the nice thing about foiling all this out is I'm going to get, and I'll just write this, the square root of x plus 1 plus h squared minus the square root of x plus 1 squared. A little cramped there, but I end up getting that, and then times h times the conjugating factor. Square root of x plus h plus 1 plus the square root of x plus 1. Now, a lot of people FOIL this out. I saw this on the quiz. Don't mess with the denominator here. Don't mess with the term without the square roots originally, because what you're going to want to do is simplify this top, and then you'll be able to cancel. Okay, you want to be able to cancel, and if you FOIL it out, you're going to end up in a position where you can't see what cancels. Okay, so I have the limit as h goes to 0. The square roots and the square cancel, so I get x plus h plus 1 minus x plus 1. Be really careful with that minus sign. Okay, over h times that conjugating factor. All right, the denominator is not changing. Yes, you need to write it out each time. Get in the habit of writing things correctly. Now, what we're going to do is distribute this -1. So I'll do that in this step. So this is equal to the limit as h goes to 0 of x plus h plus 1 minus x minus 1. So I'll get h times the square root of x plus h plus 1 plus the square root of x plus 1. Alright, so on the top, the 1's cancel, the x's cancel, and I'm left with just this. Now, a lot of people, they also cancel the h's here. You shouldn't really do that, because whenever you're canceling things, you should keep it basically to, you're going to cancel everything that cancels on the numerator and denominator all in one go. Then you're going to cancel across the fraction. Those are separate steps. Yes, it means you have to write something a little extra, but anything you do for your reader is good. Now, a lot of people leave their problems like this. Also, make sure you make that fraction bar over the entire thing. Okay. And so I get the limit as h goes to 0. And remember, this is 1 over, well, that's sloppy. It's 1 over the square root of x plus h plus 1 plus the square root of x plus 1. And now we should be able to plug in h equals 0 to get our value out. Right, so we get 1 over the square root of x plus 1, and I plugged in 0 there, or the square root of x plus 1. Actually, maybe I should write that for you. Plus 0 plus 1 in there. I plugged in the 0. So this ends up being 1 over 2 times the square root of x plus 1. Can you leave it like this? As far as I'm concerned, yes. Okay, as far as I'm concerned, yes. But your homework online, or when you check your answer in the back of the book, they might do this number right here, where they reconjugate to get that square root in the top. Right, and so they would get the square root of x plus 1 over 2 times x plus 1. Now, I don't really care about that, but if you check your answer in the back of the book and you see this and you think, but you had this, and you think, oh man, I did something wrong, you really didn't. You just didn't do that final step the book decided to do. Okay, so we have that f prime of x is essentially 1 over 2 times the square root of x plus 1. And I actually prefer to leave it this way because it's going to match some of the rules we find later on. Okay, so those are two more tougher examples of how you calculate limits by hand using the limit definition, or excuse me, calculating derivatives using the limit definition. And we will start to utilize this to help us find patterns and help us, find quicker ways of doing this. So, until next time, cheers.